Hey there, Mr. Farrell here. I just got back from the grocery, and as usual, I was thinking about parallel lines. Now look at this crate that all these strawberries are piled on top of. And look at these parallel lines. Now look at this. I was just thinking about this. You get a parallel line here, and even one way down here. And then you got this other line like this. That could be called a transversal that went all the way through those parallel lines. But if you had to cut this piece of wood, and let's just say that this was a 35-degree angle, right? You measured it with a protractor, 35 degrees right there. That one right there, 35 degrees. Well, what is this one up here? So if I try to measure that, well, if I measure it, that's going to be 145. Because those two added together, they always have to add up to 180 degrees. Added together, 180 degrees. If they're cut by a transversal. Those are called, what is it? They call it same side interior. Same side interior. Same side of this line, right here, same side of this line, and inside the parallel line, same side interior. So that's pretty cool, same side interior. So if you cut this angle here, you would know what to cut that angle over there just to make sure that you got it right, especially if you didn't have it all set up on your saw like that. Interesting. Man, I love cookies. You know what makes cookies taste better? Yup, parallel lines. Check this out. Right there on these cookies. So look at this. Here's a parallel line right here. And it's parallel with this line down here. And then we could say this right here is a transversal. It cuts right through those parallel lines. Now if we measured, let's see, this one right there, if we said that that is 70 degrees, we measured it with a protractor, guess what? That one down there is also 70 degrees. Now that's called alternate interior angles. Alternate interior, it's inside the parallel lines, and on alternate sides of that transversal, alternate interior angles. They're always equal if a transversal cuts parallel lines, especially on a cookie. Yum! So before I left the store, I had to stop and look at the magazine rack. There was a video game magazine, and they were doing a review of this game. They didn't like it very much. Look, finishes a disappointing 4 over par. But anyway, I thought it was pretty cool because it had one thing going for it. Yup, parallel lines. Check this out. Right there. So let's take a look at these things. You got all these parallel lines, right? Oop, let me draw a picture here. You got a parallel line here, and a parallel line there, and you could do another parallel line there, and even one way down there if you wanted to. And then you could say, let's take a look at this. Here's a line that goes through this thing, even a parallel line way up there. These are all parallel lines, and that's the transversal. So check this out. If we look at, say, how about this angle right up there, and we say that angle is, how about we say it's 55 degrees, 55 degrees for that angle. Guess what? This angle, this angle, this angle, even that angle way down there. They're all 55. 55, 55, 55, 55. They're corresponding angles. They're in the same spot right there in that upper left-hand corner. If you think about these 4 angles, 1, 2, 3, 4, it's in that upper left-hand corner. They're all 55, which means, well, don't forget, you got vertical angles, so the one on the other side is 55. And then right next to it, what do they got to add up to? They have to add up to 180 degrees. So that's got to be, let me see, that's got to be 125 degrees. 125. Let me draw that. 125. Now that's called a linear pair. Don't forget that. They're right next to each other. Adjacent angles right next to each other form a straight line. One is 55, the other one is 125. Got to add to 180. Okay. That's some good stuff with parallel lines. Hope that helps with your homework assignments. Anyway, that's what we'll be covering the next couple of days. I'll talk to you later. Bye.